So we go in here? Yes, we are. Okay, so we're on the second part of the review. Question number 16. Question number 16. Okay, so number 16 says the point 12, negative 5 is not on the unit circle. Find all 6 trig functions. So it's been a while since I did a question like this. So 12, negative 5 is not on the unit circle. You guys remember what we do? If it's not on the unit circle, draw a picture. We draw a picture, and we're going back to like 5th, 6th grade, and you know how to plot points, okay? Just plot the point 12, negative 5. So 12, negative 5 is 12 to the right. Negative 5 is down here. We plot this point right here. And we also plot 0, 0, and then we connect them. And then in case you forgot, you make a triangle out of this, and you always connect it to the x-axis. You draw it straight up. Okay, put 12 right here. We have a right triangle, okay? And I'm going to label this right here as 12, and this is negative. I'm going to do it like that. We're going to 12 to the right and down 5, okay? And if you want, in order to find the hypotenuse, in our reference angle, theta, always comes out of 0, 0. And you could use the Pythagorean theorem on this one, but I did tell you 2 different triangles that you really should memorize is 3, 4, 5 and 5, 12, 13. Okay, so if that's 12 and that's negative 5, that's going to be 13. And remember, the hypotenuse is always positive. It's always positive, okay? And again, if you don't remember 5, 12, 13, use the Pythagorean theorem. You'll find out that it's 13. Hypotenuse is always positive. So, sine of the angle, cosine, and tangent of the angle, cotangent, secant, and cosecant. And again, you guys have had me, most of you had me previously before. This turned out to be a special triangle. Do you think the one on the quiz is going to be a special triangle? Yeah. Okay. It may not be 5, 12, 13. It might be 3, 4, 5. And it might be, negatives, certain different spots, but it's still, it might not be the point 12, negative 5. It might be negative 5, negative 12 be the point you'll use, but it's still going to be a special triangle. Okay, you got an SOHCAHTOA. Sine is opposite over hypotenuse, negative 5 over 13. So cosecant is negative 13 over 5. Cosine is adjacent over hypotenuse, so 12 over 13. So secant is 13 over 12. And tangent is opposite over adjacent, negative 5 twelfths, so cotangent is negative 12 fifths. Okay. So since it's this nice special triangle, you're not going to have any radicals on your test on that particular question. Number 17, find the cotangent of what? 17 pi over 4. Okay, so what I would do is this. If you don't already have your unit circles out, you might want to get them out. You're going to need them. And again, you can't use these unit circles on your quiz. I'll give you a filled out unit, and all it's going to have is just the unit circle. All the stuff that you've written on the back of your unit circle, that won't be there. Okay, it'll be just the filled out unit circle. So I would actually divide this out, making a mixed number. 4 goes into 17, 4 and 1 left over, 4 and 1/4 pies. So we want to go to 4 and 1/4 pies. 4 pies, that's 2 pies, that's 4 pies. So you're going to look at 1/4 pi, you're going to look at about 45 degrees, okay? Or pi over 4 radians, same thing. And to find cotangent, you find the tangent that's written down and flip it. What's a tangent? 1? Flip it, it's still 1.
Do you have to put a dot or an arrow when it ends, or
Oh.
does it not matter?
You mean this right here? You don't have to even draw a picture. You don't have to. I was just showing that you went around twice and then one other quarter. So you don't need to. On question number 1. Question number 1. Question number 1 you need to. That's why I'm actually asking you to draw an angle.
So do you need an arrow or just a dot?
When you're actually drawing it, what you should do is you should go, that's your original. It should look like that. If you're drawing an angle, like question number 1. All right, number 18. Cosine of theta is something, and tangent of theta is something else. And at this level, I should, I expect you be able to know these, but you got to know what they'll say. Cosine of theta is greater than 0. So you should be able to describe this in one word. If cosine is bigger than 0, numbers bigger than 0 are called positive numbers. So cosine's positive, What? What direction is cosine positive? Huh?
Right.
To the right.
Yeah.
Cosine's positive to the right. Now, you can't really just say up, down, left, right for tangent, okay? Tangent is less than 0, tangent's negative. Well, it's gotta be to the right, it's gotta be either here or here. Where is tangent negative? Is it negative top right or bottom right? Bottom right. And you can't just say, if you say bottom right on your test, I'm taking points off, okay? You gotta know that this is quadrant. And if you put 4 like that, I'm gonna take a point off. Quadrants are Roman numerals, okay? So quadrant 1, quadrant 2, quadrant 3, quadrant 4. Okay? So it's gotta be Roman numeral 4. Why are they Roman numerals? I don't know, but they are. Whoever came up with this way back when decided to use Roman numerals for the quadrants. Number 19, I'm gonna move this over here. Okay, number 19, the sine theta is negative 1/3. Cosine of theta is negative 2 radical 2 over 3. I want the other 4 trig functions. So, I need tangent, cotangent, secant, and cosecant. Okay, I'm going to find cosecant first. That's the easiest of them all. To find cosecant, you flip sine. You flip negative 1 over 3, you have negative 3 over 1, which is just negative 3. I'm going to find secant next. It really doesn't matter what I find next, but I'm going to find what order you do them in. To find secant, you flip cosine, which is going to be 3 over negative 2 radical 2. But you can't have radicals on the bottom. 3 times the top and the bottom are radical 2. 3 times radical 2 is 3 radical 2. Negative 2 radical 2 times radical 2. Radical 2 times radical 2 is radical 4, which is 2. Times negative 2 is negative 4. Radical 2 times radical 2 is radical 4, which is 2. Times negative 2 is negative 4. And then tangent, you've got to know that tangent is sine over cosine. So we have this fraction over this fraction. A negative over negative is a positive. The 3's cancel. So we're left with positive 1 over 2 radical 2. I'm going to write that down even though that's not my final answer. I'm actually going to skip for a second. I'm going to do cotangent right now. Well, this isn't done, but I'm going to flip 1 over 2 radical 2. That's 2 radical 2 over 1. Let's backtrack here. I want to make sure I don't want to lose anybody here. A negative over negative is a positive. The 3's cancel, so we're left with 1 over 2 radical 2. I flipped that to make it 2 radical 2 over 1. Now we got to go back here though. We can't have a radical on bottom. Times radical 2 times radical 2. 1 times radical 2 is radical 2. Radical 2 times radical 2 is radical 4 times 2 is 4. Any question on that one? Number 20. Sine is negative 5/13. And they tell us theta's in quadrant 3. Theta's in quadrant 3. So I'm going to draw a picture. The angle's in quadrant 3. What other quadrant could it have possibly been in? Not 1. Sine is negative. What direction? What direction? Sine, yes ma'am. Yep. Sine's negative down, so it could have been in 3 or, could have been 3 or 4. It's in 3 because I said it's in 3. Okay? So theta's right here. Sine is opposite over hypotenuse. Opposite is 5. Hypotenuse is 13. Does the negative go on the, does it matter where the negative goes? It goes on the 5 for 2 reasons. 5 is definitely negative because it's going down. And 13 is hypotenuse, which is always positive. Okay? Hey, 5, 13, that's what?
12.
Is it 12?
Negative.
Why?
Because it's left.
It's negative 12. Okay. So again, sine, cosine, and tangent. Cotangent, secant, cosecant. Sine, they told us, is negative 5/13, so cosecant's negative 13/5. Cosine, adjacent over hypotenuse, is negative 12/13. So secant's 13 over negative 12. And tangent is opposite over adjacent, negative 5 over negative 12. If you left it as negative 5 over negative 12, I probably wouldn't mark you wrong. I should take a point off, but negative 5 over negative 12 is positive 5/12. So I probably wouldn't mark you wrong. I should take off a point, but you should simplify it whenever possible. Okay, 21. Secant's 2. Sine is less than 0. Okay, I want the other 5 trig functions. So I'm going to draw a picture here. Let's see. Sine is, well, it says secant is 2. What else do we know? If secant is 2, cosine is 1/2. I'm going to write that up here. Cosine is 1/2. Okay? As secant's reciprocal is cosine, reciprocal of 2 is 1 over 2. Okay, so sine is negative down. So it's down here. The cosine's positive, so it's got to be to the right. Okay, so sine's negative, so it's down. Cosine's positive to the right. So down and to the right in quadrant 4. Okay, cosine is 1 over 2. Cosine is adjacent over hypotenuse. Is that a special triangle or not? No. So, we have, label that x. 1 squared plus x squared is 2 squared, using the Pythagorean theorem. 1 plus x squared is 4. Subtract 1 to each side. X squared is 3. Square root. X is plus or minus radical 3. Which is it, plus or minus? How come minus? Down. So it's negative radical 3. And again, sine, cosine, tangent of the angle. Actually, I tell you what, is there a shorter way you could have done this particular problem? As soon as I said cosine is a half, you could have looked at the unit circle. You could have. And I don't care if you do. Okay? You could have looked at the unit circle. Cotangent, secant, and cosecant. Okay, so give us cosine's half, secant's 2. Gave us that. Sine is opposite, negative radical 3 over hypotenuse, 2. Cosecant would be 2 over negative radical 3. We times radical 3 though, on top and bottom. We have 2 radical 3 over radical 3 times radical 3 is radical 9, which is 3. And tangent is sine, well, opposite over adjacent. Negative radical 3 over 1, which is negative radical 3. Reciprocal radical 3 is radical 3 over 3. Okay, that's the last of the long questions. The rest of these are going to be real short with hardly any writing. Okay, 22. True or false? Okay, tangent of negative 30 degrees is the tangent of 30 degrees. Okay, and I'm going to tell you right now, there's only one right answer. But on the question I give you on the quiz, for question number 22, your answer is going to be, well, first off, is that a true statement? Is tangent of negative 30 the same as tangent of positive 30? No, that's false. And I'm really only looking for a 2-word explanation. Why is it false? Huh? Yeah, but how about this? If I said the cosine of 10 degrees, negative 10 degrees, equals the cosine of 10 degrees, true or false?
True.
That's true. Why? What's even? Cosine, 2 words. Cosine's even. It's true because cosine is even. That's your explanation. Why is that false? What's odd? Tangent's odd. That's your explanation. It's the only acceptable answer. You're going to say true because it's an even function, or you're going to say false because it's not an even function. It's not a function, whatever I give you. Okay? So, I don't know what the cosine of 10 degrees is. I don't know what the cosine of negative 10 degrees is, but they're the same. Okay? Question on that one. As long as you remember cosine and secant are the only ones that are even, that should be an easy one. 23. You can't miss this one, okay? You can't. Sine squared of 17 degrees plus cosine squared of 17 degrees. Sine squared plus cosine squared, as long as the angle is the same, and it is, it always equals what? 1. I don't expect to see any work on that. Okay, sine squared plus cosine squared is 1 as long as the angle is the same, and it will be on your test, on your quiz. Okay, sine of 40 degrees. I do expect to see a little bit of work on this, but not much. Okay, you should not need a calculator for this. The sine of 40 degrees times the cosecant of 40 degrees. Our angles are the same. Is that a good thing or a bad thing? That's a great thing. Okay, we want them to be the same. But they're not the same trig functions. We have sine of 40 and cosecant of 40. How could I make them have the same trig function? What is cosecant?
You flip it reciprocal.
It's reciprocal of what?
Of sine.
So, what's the reciprocal of sine? 1 over sine. Now, not only are the angles the same, the trig functions are the same. Now what can we do? You could, but I see something on top and bottom. This is 1. Like I said, I expect to show you work, and what work do you show? What I did. That's all the work you need to show. Okay, tangent of 200, cotangent 20. Tangent of 200, cotangent of 20. Okay. Angles aren't the same. That's not good. We want them to be the same. How can I make them this? Now be careful here. Some students say, well, if you divide this by 10, they're the same. Yeah, but you're changing the angle. Yes, sir.
Can't you minus by like 180?
Why can you do that? You're right. You definitely can minus 180. Why? What's the period of tangent? How far do you have to go in order for not all the way around, only halfway around, 180 degrees. Okay? So, tangent of 20 degrees times a cotangent of 20 degrees. Okay? That's better because the angles are the same now. Now, I want to make sure you guys understand. True or false? A 20-degree angle and a 200-degree angle, they're the same thing? No. But the tangent of 20 degrees and the tangent of 200 degrees are the same. Okay? So, same with this, okay? Is a 405-degree angle the same as a 45-degree angle? No. 405 is all the way around and then another 45 degrees, okay? I mean, that's like saying, you know, 2 kids go out on track practice and they're at the starting line and I say, okay, go run 8 laps. And I come back 20 minutes later and I see them both standing at the starting line. And one kid ran 8 laps, the other kid just stood there and watched them the whole time, okay? They do the same thing? No. They're in the same spot at the end, but they didn't do the same thing. One kid ran 8 laps, the other kid just sat there or stood there, okay? So, this, if I subtract 360, they're the same angle. The sine is the same as those, but not the angle itself. Cotangent is the same as what? 1 over tangent of 20. Those cancel and left with 1 again. So are the answers to the last 2 questions on your quiz 1 and 1? Not necessarily, but they're going to be very similar type questions. Okay. So and just be careful because I might ask you something like this. Try to make one up here real quick. I might ask you for the cosine of 35 degrees minus the, or plus the, no, I can't give it. I'll give you a better one tomorrow. I'm trying to make one up on the fly and I can't. Questions on this? Okay, Luke, you want to look over those first 15 and you have questions, either ask me or somebody else? And, okay, so tomorrow when you come into class, I'm going to give you this exact same review sheet. We're gonna treat it like a quiz, and then you'll get your actual quiz on Thursday. So, all right, rest of the time's yours to work on whatever.